Welcome to G Fun Facts Online. Our planet feels solid beneath our feet, but it's anything but quiet. It is in constant, grinding motion. Tectonic plates are always moving, building up stress that gets released as earthquakes. We all know about the big ones, the quakes that can level cities in minutes. But what about the quakes we don't feel? The millions of tiny, subtle tremors that happen every single day, completely undetected by our traditional instruments. These are the hidden earthquakes, and they hold the secret story of our planet's behavior. For the first time, thanks to the power of artificial intelligence, we are finally learning to hear this silent shaking. We're entering a new age of what scientists call forensic seismology, a field that's being completely transformed by AI, unlocking a treasure trove of data we never knew existed. Forensic seismology is the science of using seismic waves, the vibrations that travel through the Earth, to understand events that have already happened. For decades, its most famous job has been playing detective on a global scale, specifically in detecting underground nuclear explosions. This was critical for verifying international treaties. Seismologists became experts at looking at a seismogram, the squiggly line readout of seismic activity, and telling the difference between a man-made blast and a natural earthquake. A nuclear explosion creates a sharp outward push, a compressional signature. A natural earthquake, caused by plates shearing past each other, has a much more complex wiggle. Scientists would meticulously analyze the arrival times of the different waves, like the fast-moving primary P waves and the slower, more destructive secondary S waves. They'd compare the strength of waves traveling through the Earth's body to those on the surface. But this discipline wasn't just about bombs. Forensic seismology has been used to analyze the catastrophic explosion of the Russian submarine Kursk, and even to track the movement and calving of massive icebergs. But these traditional methods had a big problem. They relied heavily on human experts staring at data, a process that is incredibly slow and, more importantly, prone to missing the small stuff. Tiny earthquakes, often called microquakes, are easily lost in the constant background noise of the planet. This isn't just silence. It's a hum of everything from crashing ocean waves on a distant shore to the rumble of a truck driving down a nearby highway. These faint signals were simply invisible. This is where the game has completely changed. Artificial intelligence is not just a small improvement here, it's a paradigm shift. Using machine learning and deep learning, scientists can now sift through colossal mountains of seismic data with a speed and accuracy that was unimaginable a decade ago. The process is conceptually simple. You take an AI model and you train it on a massive labeled dataset. This dataset contains the waveforms from hundreds of thousands of confirmed, real earthquakes. But just as importantly, it also contains a huge variety of seismic noise. Through this intensive training, the AI learns to spot the unique, telltale signature of an earthquake and distinguish it from all the other vibrations happening around the world. Several incredible AI models are leading this revolution. For example, researchers at Stanford University developed a model called PhaseNet. It excels at one of the most fundamental tasks in seismology, picking out the precise arrival times of P waves and S waves from the noise. Another model, named CRED, was actually inspired by the voice trigger algorithms in our virtual assistants, like Alexa or Siri. Just as your phone learns to recognize your voice saying a wake word, CRED learned to recognize the voice of an earthquake. But perhaps the most powerful tool in this new arsenal is the earthquake transformer. This is a deep learning model so sophisticated it can detect tiny earthquakes with signals so weak they are completely invisible to conventional methods. The impact of these AI detectives is staggering. Let me give you the most dramatic example to date. Researchers took 15 years of historical seismic data from the Yellowstone caldera. Yellowstone is one of the most seismically active volcanic networks on Earth, a place where the ground is constantly rumbling. They fed all this historical data, which had already been analyzed by humans, into a machine learning model. The results were mind-blowing. The AI uncovered over 86,000 previously unknown hidden earthquakes. That's a tenfold increase over the existing official catalog. Think about that. For every one earthquake we knew about, there were 9 others hiding in the data. Seismologists are calling this a data mining gold rush, revisiting old datasets from around the world and painting a picture of our planet that is vastly more detailed and active than we ever imagined. Now you might be thinking, okay, so we found more tiny earthquakes, so what? But uncovering these hidden tremors is so much more than just adding entries to a catalog. Each newly discovered quake is a vital piece of a much larger puzzle. By analyzing the patterns of these microquakes, scientists can identify fault lines that we never knew existed. They can see how stress is building and shifting on known faults with unprecedented detail. The Yellowstone study, for instance, revealed something fascinating. More than half of those 86,000 new earthquakes were part of what are called swarms, dense clusters of small, interconnected quakes that can last for days or even months. These swarms are believed to be caused by the movement of underground fluids like magma and hot water, essentially giving us a map of the volcanic plumbing deep beneath the surface. This has profound implications for assessing seismic hazards. When you have a more complete record of past earthquakes, you can better understand where stress is accumulating. This allows scientists to improve forecasts about the likelihood of future, larger quakes. This information is absolutely vital for developing more accurate seismic hazard maps, which, in turn, inform building codes and emergency preparedness plans in places like California, Japan, and other earthquake-prone regions. The benefits don't stop there. This technology is also making earthquake early warning systems much better. These systems, which are already in place in several countries, work by detecting the initial, less destructive P waves of a quake. This gives a few precious, vital seconds of warning before the more damaging S waves arrive. A few seconds is enough time for automated systems to shut down gas lines, stop high-speed trains, and alert the public to take cover. The problem has always been false alarms, triggered by other vibrations. But now, AI models, like a type called Generative Adversarial Networks, or GANs, are being trained to distinguish between the first pulses of an earthquake's P wave and other random noise with incredible accuracy. Fewer false alarms means people will trust the system more, and when the real alert comes, they will act. It can literally be the difference between life and death. And just as AI is helping us find natural hidden earthquakes, it's also making the traditional job of forensic seismology, distinguishing between natural and man-made events, much more powerful. This is especially crucial for monitoring the Comprehensive Nuclear Test Ban Treaty. While a human expert can spot the signs of a nuclear test, an AI can do it faster, more reliably, and by analyzing subtle features in the waveform data that a human might miss. By training models on the known signatures of past explosions and countless earthquakes, AI algorithms can learn to tell them apart with an extremely high degree of confidence. This improves our global ability to verify that countries are abiding by the treaty. And this capability isn't just for nuclear explosions. It can also be used to identify the seismic signals from large mining blasts, gas pipeline ruptures, and even rocket launches, giving us a clearer picture of human activity that shakes the ground. The future of this field lies in integration. The next step is to combine AI analysis of seismic data with a whole range of other data sources. For example, a technology called INSAR, which uses satellites to detect tiny changes in ground elevation, can spot ground deformation caused by magma movement or stress on a fault. Deep learning models are already being used to scan INSAR data to find subtle ground movements linked to small earthquakes that might not even generate a detectable seismic wave. Fusing these technologies gives us a more complete, multifaceted view of the Earth's processes. Imagine a future where a global, AI-powered system continuously analyzes real-time data from a worldwide network of sensors. Not just seismometers, but also GPS stations tracking plate movement, satellites like INSAR watching from above, and even infrasound detectors that listen for low-frequency sound waves. This integrated approach will allow for a truly holistic forensic analysis of our planet. Of course, like with any powerful new technology, there are challenges. One of the biggest in AI is the black box problem. A complex deep learning model can be so intricate that even its creators don't know exactly how it's making its decisions. This lack of transparency is a problem in a scientific field that is built on clear, evidence-based reasoning. To solve this, researchers are developing a new field called Explainable AI, or XAI. The goal of XAI is to create models that are not only accurate, but also interpretable. They can show their work, highlighting what parts of the data led to a certain conclusion. This allows scientists to have greater confidence in the AI's results, and can even lead to new scientific insights by revealing patterns they hadn't considered. The journey of AI in seismology is really just beginning. As the technology gets better and our datasets get even bigger, we are going to uncover more and more of our planet's hidden secrets. From the silent tremors that signal the stirring of a supervolcano to the faint rumble of a clandestine explosion thousands of miles away, AI is giving us a new set of ears to listen to the Earth. This is more than just a tech revolution. It's a fundamental shift in our ability to understand the dynamic, complex, and often turbulent world right beneath our feet, ultimately paving the way for a safer and more resilient future for everyone. Thanks for tuning in to Fun Facts Online.